Hello, folks. Welcome to today's lecture. In this lesson, I'm going to talk about Introduction to C# Collections, for C#.net. The material comes from my book, C# for Artists, 2nd edition, Chapter 14. And this is a picture of my dog, Schmoogle. Okay, learning objectives. Describe the purpose of a collection. List and describe the classes, interfaces, and structures contained in the system collections namespace, in the system collections generic namespace, and system collections object model namespaces. State the general performance characteristics of arrays, lists, trees, and hash tables. State the general operational characteristics of stacks and queues. Choose a collection based on anticipated usage requirements, etc., etc. We're not going to be talking about all these learning objectives in this particular lecture. I've split this chapter into 6 lectures. So this will just be first couple sections in the book to give you a broad introduction to the power of collections. In fact, I just devote one chapter in the C# for Artists book on collections, and then use them throughout the book where necessary. I have written an entire book on collections. That's how powerful they are. And I go into detail on their usage, and you combine them with multi-threaded programming and notifications, and you get some really powerful constructs from the C# collections name, or from the .NET collections namespace, I should say. Saves you a lot of time and trouble in your coding. In fact, when you consider all the functional assets of the .NET Framework, I believe, in my opinion, none possess the extraordinary potential to save you more time than the collections framework. It spans 4 namespaces. I forgot to mention the system collection specialized, but the interfaces, classes, and structures belonging to the collections framework make it easy and convenient to manipulate collections of objects. Okay, so the first part of this chapter is just an introduction. I go into detail into, the difference between pre-.NET 2.0, where everything was an object, to the generic collections. Okay, but first I start off with a case study to demonstrate its power. So for this case study, imagine for a moment you're working on a project and you're new to C#, and but you're a pretty good coder, so you got some chops, and you're deep in the code. You're in the flow, and you don't want to stop to read no stinking documentation. And the problem at hand dictates the need for an array with special powers. Okay, one that automatically grows itself when too many elements are inserted. So to solve the problem, you hastily crank out the code for a class named dynamic array. So let me pull up the code for this class. All right, let me switch on my VM here. So all the source code's available from my Pulp Free Press website. Just go to the support site for the C# for Artists 2nd edition book, and click on the source code. It's chapter 14, and we'll call this one Dynamic Array. So let me crank up Notepad here, get rid of that code, and just load up the Dynamic Array class. Okay, so at the heart of the dynamic array is an array of objects here. I've declared on line 13 a field I'm calling object array, _object array, and setting it to null. I've got a couple more private fields. Next open element, which I initialized to 0. Growth increment is 10. And I'll show you how that's used here in a second. Private constant. So I created a constant called initial size 25. And I have a property here, starting on line 18, called count. So it just returns the next open element. Now, the next property is an indexer. And if you're not familiar with this type of a property, well, it's not necessarily a property. It's a different member. Okay, so in a class you can have, methods, properties, fields, right? Indexers are another one of the type of members that you can have. So when you implement an indexer, it allows you to treat your object as like an array. So essentially what you're doing is you're implementing the capability using an indexer to access whatever your object has, like you would an array. And since our class has an array field, we want to get at that array via an instance of our class without accessing the field object array. So we want to just implement an indexer. And this is a great way, or a great instance of the way that you use an indexer, okay? So I have a get and a set, right? A getter and a setter section here for my indexer. And essentially, I'm doing a couple, some idiot checking. I'm saying, hey, if the index is greater than equal to 0, which you want it to be, and the index is less than the length of the array, because you don't want to go, you don't want to access the beginning prior to the beginning. And, of course, the Dotnet Framework is not going to let you do that anyway, or I should say the Dotnet runtime. That's a beautiful thing about these managed objects, right, or this managed environment, is that it imposes array bounds checking on you, which was a limitation of early languages like C and C++. So we check to make sure that we're in the bounds of this array. And you're not seeing things. So if I move my cursor like really fast back and forth, the pointer gets bigger, right? So that's kind of bizarre. Okay, so once I get past my check, then I'm going to say, okay, fine. My indexer is within my bounds, so I'm going to go ahead and return the object that you're looking for, or the element that you're looking for. Else, I'm going to return null. And then my set, and I've got a comment here. Set ignores index parameter in functions like the add method. Okay, so I put that in there because I'll talk about that here in a second. If next open element is less than object array.length, in other words, if I've got room in my array, right, to put the element in, then I'm going to go ahead and insert, right, the incoming value, right? If you're not, so this is kind of like a property, right? I'm going to be assigning something, right, for the setter piece, to go someplace into my array. So if you're not used to C# properties, which probably if you're watching this video you are, then you'll notice that value isn't defined anywhere within this indexer, right? Value represents the incoming right-hand side value of when I make an assignment to this particular, index element, right, or array element. So value, right, is a I guess a reserved word, I suppose, in the context of writing a property or an indexer. So the incoming value I'm going to assign to this element, right, is going to be put in the next open element spot, and then I'm going to, as soon as I make that insertion, I'm incrementing next open element. Now, if I don't have enough space, I'm going to call grow array, and grow array is a method that I've defined down here later on in the code. Okay, so I'm going to have to choke up here on this window so I can show you that, and I'll go through grow array in a second. Sometimes I have a problem saying that word. Don't know why. Okay, and then once I call grow array, I then make the insertion, right? If I couldn't make it up here, I'd do it down here. Now I have a constructor, which begins on line 38. This constructor takes a size argument, okay? And then it creates the object array using, new object, whatever size I want it to go. The default constructor, on the other hand, will actually call this constructor using the constant initial size, and I'll get an array of size 25, okay, to start off with. Now, I have an add method, okay, because I want this to kind of look like, I want to be able to add stuff to it. The whole purpose of me writing this code was to create an array with superpowers, right? So I want to add stuff to my array. So I have an add method, and I'm going to add objects, all right? So then I do another comparison. If next open element is less than the array.length, then go ahead and insert the element, or the object, I should say, at that element, and then increment next open element. Now, if I don't have the space, so this code looks a whole lot like this piece up here. I just call grow array, and then make the insertion once I've grown the array. Now the grow array method, that's killing me. Private void grow array, all right. Object array. So I got to create a temp. So I've got this array, object array field in my class. And what I need to do is take all those objects that are in that array, stick them in a temporary array, make a bigger array for my field, and the growth factor is going to come into play here to make that happen. So the first on line 54, I create my temporary array, and I assign to it the object, the currently existing object array. And then I recreate another array. I say object array equals new object, and then our object array.length plus growth element. A growth increment, I should say, growth increment. And then I say for int I equals 0, j equals 0, I less than temp array.length I plus plus. If temp array I not equal to null, in other words, if I have any null references in that array, or if any of the elements point to null or are null, then skip them. Otherwise, copy those objects over. So object array j plus plus equals temp array I, and I'm controlling the increment of the j. And then I set, and once I've done all that, copy, and then I set next open element to whatever the j's value is, because that's the next open element of my new array. Then I sent the temp array to null, okay, which is really not necessary because it'll get garbage collected as soon as this method goes away, but I just forced the issue right there. And that's it, okay? So now let me show you some code that uses this in a method, or in a test, okay? So the name of my test application is called Test Array App, and it's not very big. So there we go. The class is called Test Array App, and it has one big main method. And then I'm using my dynamic array here to create me a new dynamic array, which I call DA. And I say console.writeLine, the array contains DA count. So initially it'll contain no elements. And then I'll say add, so DA.add, and then I'm going to put in a string. Because I can put objects in, I can put anything in this array, or in my dynamic array. And then I can say console.writeLine DA, element 0.toString. And should print out the contents of element 0, which would be, if you love C# like I love C#. Now, the whole purpose of this for loop is to add integers to the point where it forces the array growth, because I use the default constructor up here, and it gave me an internal array length of 25 elements. And what I want to do is I've already inserted one, so I'm going to insert, a couple more, and then I'm going to grow that. It should grow itself dynamically with the grow array method. So for int I equals 1, okay, because I've already used up element 0 here, I less than 26. So go from 1 to 25. I plus plus. So what's going to happen is I'm going to try to insert a 25th element, and I'm not going to be able to, because really the array goes from a 25 element array goes from 0 to, length minus 1. So I should say, the size minus 1. So a 25 element array, I go from 0 to 24. 24 is my last indexer. So I've already put one here in element 0. This will be the second element I'm going to insert, and I want to make sure I go 1 over. Okay, and that will say, oh, hey, there's no more room in this array to insert anything else. So you're going to have to grow. Okay, so that will force the growth. So I go through that for loop, and at the end of that for loop, I should have an array that contains, 25 objects, I think, at this point. And then I'll go through, I'll do another for loop. And I'll say int I equals 0, I less than da.count, I plus plus. If dai not equal to null, console write da.i.toString plus a comma. All right. And then console.writeLine to give me another blank space. So let's go ahead and take a look at this code in action. I'm going to minimize Notepad++. I'm going to crank open my console. I'm going to change directory to the dynamic array folder, and I'm going to compile all that code. So C sc star.cs, and I can compile both of these together because there's nothing special going on here. So clear screen and dynamic array. Let me see what I call it, array test app. So let's go back here and hit return. So the array starts off contains 0 objects, and then I print out the first one, or 0th element, the first element. Then the array contains 26 objects after I've went through and inserted all the integers, and it says, then I go through and print them all. Okay, and that's it. That's the way it works. Now you're probably scratching your head. It's like, okay, so why'd you do that? Well, I did it to make a point, and that is, it works. It works. It's not perfect. There's probably some bugs in there I don't know about, but it suffers, from several shortcomings. For example, you can access each element of the array, but you can't remove elements. You could add a method called remove, but what happens when the number of remaining elements falls below a certain threshold? Do you want to shrink the array as well? And then another point to consider is how to insert references to specific element locations. And when this happens, you must make room for the reference at the specified index location and shift the remaining elements to the right. And if you plan to frequently shift insert elements into your custom built dynamic array, then you have a performance issue on your hands that you probably didn't foresee. So in other words, you could custom code some of this stuff, but a lot of this work is already done for you. So let's go ahead and rewrite this program, this array test app, using a collection. All right. And it turns out we don't have to really change much to make this happen. Okay. So I'm going to go to my next example code. Now I'm going to close these two programs here, and let's go to using array list. So this would be the same array test app. But I've made a couple changes actually, not very many. One is I've added a using system.collections directive. So I'm using the classes and interfaces that are in the system collections namespace. I've changed dynamic array, right, which the code that I wrote, to array list. And creating an array list. Now let's take a look at the book here. So here we have iList. So 14. Okay, this is the first modification to it, iList. I could change this. I'm going to go back here and change this to iList. Okay, that makes it the same as the book. And it'll still work. So console.writeLine, all this other code down here stays the same. The only thing I've done is I've changed this to iList. Okay, I can use both. I can actually use array list as well, but in the book I've got iList equals new array list. Okay, and the important thing is that iList has an interface, and it just so happens when I wrote dynamic array, it would be by sheer luck, right? Normally, but I put an add method. I gave it an indexer, so that's exactly the things that iList provides. All the other code stays exactly the same. So let's go back to this. I'm going to change directories. I want to see if I got the code right here. That's probably the code right there. In fact, let me check. Even I forget where I put things. I'll put this back to array list. Okay. So change directory. All this code is available on the website, so you don't have to type anything in. First thing I want to do here, though, is make sure it's the same code. That's it. Oops, sorry. Nope, that's my generic stuff. Let's go back. Nice try. So back to where I was. Okay. So I can change this to iList again. Just make it the same as the book. All right, and the rest of the code stays exactly the same. So let's compile this. All right, and let's run it. All right, so we get the same exact results, and the only difference was I swapped out my dynamic array class that I, was custom code with the array list. So my type here, or my reference, is an iList, and the type that I've actually created is an array list. Now, in practice, this is something that you'd see a Java programmer do, where you have, you target the interfaces, and then you create the object that you want to, the collection object that you want to use. But in C# and .NET in general, I find that doesn't necessarily work as good as it does in Java. So really, array list is what you'd want to put here for the type. And if we compile this, we find that everything works exactly the same. Hang on. I didn't take off the CS, so it started up Dreamweaver. Let me do that again. Okay, really, there we go. Okay, so it runs with array list. Okay, so so what's the benefit? Well, there's a ton of benefits. First off, your code is not, if you custom wrote all the collection, right, that you wanted to use, and you did everything on your own, and you didn't subclass a collection or something along those lines, your code's not going to be as robust. It's not going to have been subjected to as much testing. There's probably something you're not thinking about. But if you opt instead to use the collection classes supplied by the Dotnet Framework, those things have been hammered over the years. They're pretty bulletproof. They work well. The performance is tweaked, right? And it's more robust code that you're adding to your project versus trying to do everything yourself. So it really pays dividends to get in there and study these namespaces and figure out what's available for you. Okay, a lot of what I tell my students is a lot of functionality that you want to do is probably already exists. You just got to dig and figure out what classes provide that functionality for you. Okay, so let's return to the book one more time and take a quick peek at generics. So I can modify array test app one more time, okay, and I can actually create a dynamic. So, I'm inserting objects, right, into the current program. I insert a string and I insert integers, and that's okay because it's an array of objects that and in this first example, or I should say in the first modification up here where I'm using array list, this is an old school, which you'll hear me use that term in this book a few times. And when I talk about old school collections, it's the first initial, set of collections that came out with Dotnet Framework, 1.0. And those collections, it's objects in, objects out, right? So if you were sticking in an integer and you wanted to, get an integer out, you had to know that it was an integer. If you inserted a string into an object, then you had to know what type of object it was that was inside this collection. Then you had to cast it to a string to get it out. Okay, so if you have a custom user-defined type and you inserted it or you added it to an old school collection, then when you wanted to access that, you had to cast to the proper type in order to use that user-defined type functionality. Okay, because all the array knew is all the collection knew was it contained objects. It didn't know what type of objects were in there, so you had to sort that out yourself. Well, to improve upon that, in .NET 2.0, they released the generic collections. Okay, so the second mod to this program uses a generic collection. So let's go take a look at that code. So let me close this down and pull over the list. All right, so this is the second modification. Now, in this particular mod, I'm using a different namespace. So I'm using system.collections.generic, and I'm using iList here again. And what I'm doing is I'm using a generic version. I'm actually dumbing it down and saying, hey, you're going to contain objects, but I could specify the exact type that this list contains, okay? And I can change this from iList to just list, okay? And that will work fine too. So list object DA equals new list object. So I'm going to create a list of objects, and other than the namespace change and the fact that I'm using a generic list, note that it's not an array list. It's just a list, okay? the behavior is going to be exactly the same. So let's go ahead and compile this version of the program. Okay, so that program runs exactly the same. So I had custom code that I wrote initially for my collection because I was too busy to go take a look at the collection's documentation. And then I demonstrated the old school collection array list type, which objects in, objects out. And then I used generic list to mimic the same behavior. All right, but that's just scratching the tip of the iceberg at that point. All right, so the Dotnet Framework, and as a quick review, the Dotnet Framework, collections framework, saves you a ton of time and hassle. The code's thoroughly tested. There's all kinds of classes in there to represent any type of collection that you'd usually need. Okay, they've got everything from stacks and queues to array-based lists and linked lists, along with trees, red-black trees. So you get improved performance, more robust code. So I urge you to take a look at the collections framework documentation closer and see what meets your needs. All right. And with that, I will see you in the next lecture where I'll talk about data structure performance characteristics. Have a good day.